So now what I want us to do is use these differentials to approximate. Approximation by differentials. So we're just going to look at an example here of how to do this. So use the differential dz to approximate the change in the function z, which is the square root of 4 minus x squared minus y squared, as xy moves from the point. It's going to start off at the point 1, 1, and we need a nearby point, so it's going to be to the point 1.01, 0.97. Compare this approximation with the exact change in z. So the point I'm starting with, I'm told xy starts off being the point 1, 1, and then x plus delta x, y plus delta y will be 1.01 and 0.97. So from here, I can figure out what delta x is. Delta x is 0.01, and delta y, my y coordinate went down, so it's negative 0.03. And these are also going to be my values of dy and dx. All right, so let's go back to our question. We're using the differential to approximate my change. So I'm approximating delta z with dz. And so what is dz? That's our total differential. That's the partial derivative of z with respect to x dx plus the partial derivative of z with respect to y dy. So I got to look at my function, and my function I'm going to rewrite it as an exponent here to the 1/2 power, and now let's find our partial derivative. So the partial derivative of z with respect to x be 1/2 4 minus x squared minus y squared to the negative 1/2 times negative 2x. So you'll get a negative x over the square root of 4 minus x squared minus y squared. And you'll get something similar for my partial derivative of z with respect to y. It'll be negative y over the square root of 4 minus x squared minus y squared. So now we're going to go back to delta z, which remember it's approximately dz, and I'm going to plug in, it's my partial derivative of z with respect to x dx plus my partial derivative of z with respect to y dy. So plug in our partial derivatives, minus x over 4 minus the square root of that times dx, and then minus y over the square root of 4 minus x squared minus y squared dy. So delta z is approximately, now we're going to plug in our point. So here, remember that x is 1, y is 1. Delta x we said was 0.01. Delta y was negative 0.03. So we're going to plug this stuff in here. It's negative 1 over the square root 4 minus 1 minus 1. So it'll be square root of 2 plus a negative 1 over the square root of 2. And it's negative 0.03. So if you combine these, you'll get that delta z, it's approximately 0.02 over the square root of 2, or 0.0141. So there's our approximation. But I was also asked to compare this to the exact value. The exact value of delta z. So delta z, the exact value would be f of 1.01, 0.97 minus f of 1, so this would be the square root of 4 minus 1.01 squared minus 0.97 squared. When we plug in 1 into our function, you'll get the square root 4 minus 1 minus 1. So if you use a calculator and round, you'll get approximately 0.0137. So there's the exact value, and you can see our value was pretty close for our approximation. We're not off by very much.